Thank you, Dennis. Welcome, everybody. My maths presentation. Happy that you could be here. It's about the design space for interactive photo tracking as an in-action training tool for climbers. It's a very complex title. Break it down along the way. First, I will introduce a little bit about the topic and the background of this project, after which we will then get started with the design process, which we also call ideation. Then we're going to talk about the technologies that we're going to use in the project, which are tracking technologies, after which it's time to build a prototype, which is going to be evaluated, after which some results and conclusions can be drawn. Okay, let's get started. Can I see some hands? Who of you have gone climbing before? It's a very biased question. Some of you are my participants. It's a very popular sport. It's growing in popularity. We only ride it by a pedal. And it's also one of the most dangerous. So every 1,000 climbing hours, there's already 4 to 5 injuries. And these are, of course, from falling, but also from strenuous moves, meaning you pull a muscle while doing a technique which you're not supposed to do for a certain round, or from overuse. And what we see from literature is there are a couple ways to avoid these types of issues. That is personalization, meaning personalizing or tailoring a route not just to the user skill level, but also to their stature, body proportions, and preference. And the last one is motor skill learning or motor skill acquisition by learning the correct techniques to avoid these injuries. If we look at related work, so what kind of interactive technologies, which is the study that we're doing, are present, both in science as well as commercial. We can see a lot of them use already some form of tracking, because it's just a convenient way to sense movement from a climber. But we can also see a few differences. So a lot of the applications focus on entertainment, which is just like climbing games and virtual reality games, that kind of stuff, or more training tools. But we can also see that those entertainment-focused tools are mostly in action, meaning during a climb, while these training tools are a lot of the time out of action, so between climbing, which leaves us with 2 gaps, which are useful to explore. And we're especially interested in the bottom right in-action training tools as of its implication in reducing injuries. So that's the first constraint in this project. We will be using some form of motion tracking technology. This is still very broad and will be compared and specified along the way. And it's going to all be integrated into one prototype, which is a see, think, act system. So it's going to sense something, process that, and give feedback to the user in some way. If we convert that to a research question, it will be, what is the design space for in-action training tools using motion tracking for climbers? And I have a few. This can be broken down into sub-questions, which I've summarized for you because they're all very long. First, the design method, and that is how we use co-design during our process, which means involving users. Second is find out which specific climbing opportunities and problems we're going to tackle. So that's still in the bottom right quadrant, but it basically means the problem is not yet defined and it's going to be explored along the way. Third, which tracking technology are we going to use? So really deep dive into the technology. Then we need some metrics on which the built prototype can be evaluated. And finally, how does the prototype then perform according to those metrics? Let's start our design process. This is the method that I'm going to use, or that I used. It's a typical brainstorming method that you start with a lot of ideas, which can be filtered down to arrive at one final concept, which is conventional. But I'm also going to be using 2 theories on top of that, which is co-design. This means involving users as early on in the design process as possible, in the hopes to more closely align the final concept with the user needs, as well as possibility-driven design, which is not only looking at the problems in climbing, but also the opportunities. So not just the issues, but also improve on the highlights for which there's. Okay, the first session that we're conducting interviews, just to get a little bit of more of an idea of what the climbing population looks like. And we can already see some findings there. First, these increases that I've mentioned do not stop climbers from climbing, against advice from health professionals. And just because of ambition, but also just for fun. Second is that puzzling is a key aspect of climbing environment. And with puzzling, I really mean the cognitive task of figuring out what kind of techniques you're doing on the wall to accomplish a certain route, which is really part of the challenge of climbing. And it's very important if you're designing any form of system that gives feedback to the user, as you should not spoil this process. Third is that a lot of climbers don't necessarily use a coach on a daily basis, but really learn by observing others during their climb. And the last one is that climbers tend to skip warm-up a lot. And this is an issue because warm-up is a key part of reducing injuries. Okay, from these interviews, we can already get a little bit of a more view of the climbing population. So I've made a few personas. These are 4 segments of the climbing population. Any climber will not specifically be one of these segments, but more of a combination, but it's still nice so we can target our concepts to a specific segment. These are broken down into skill level, training frequency, and training cycles. Our next session is an ideation session called body storming. So as opposed to brainstorming, which is using pen and paper basically, body storming tries to involve the body of the user. So for embodied experiences such as climbing or sports, this can be really beneficial. And we do that by reenacting climbing situations. So you don't have to imagine yourself climbing, but you can really do the embodied experience to more closely identify problems. This could have been done in a regular bouldering gym, for instance, but instead I opted for a virtual one, so virtual reality body storm. This has a couple of advantages. First, there's a faster iteration time, but it also allows you to pull in more objects and tools really fast, which can really enhance the process and allow for more exploration. And the last one is that we can choose the space that we're going to use for our body storm. And for that, I used a LiDAR scanner to scan our lab space and brought it into a virtual environment. It's called a digital twin. But basically, this allows the physical constraints of the lab space to be used during the body storm. And for the problem and solution spaces, that's not that relevant. For the solution spaces, it's really nice. So our solutions are tailored to the space. Okay, from those ideas, these knowledge fragments, as we call them, during our sessions, we can generate a few concepts. These are based on both the problems, opportunities, as well as the solutions that we generated. Of course, based on literature and tied to a specific persona that we created. Now, I don't have time to discuss all the concepts, unfortunately, but to get to a specific concept to further implement, we've asked the help of experts. And these experts can help us select one that they are they're best able to select. So I selected a climate coach. This is Irene. She is the Dutch Olympic youth team coach, also owner of local bouldering gym. She's very good at technical climbing and techniques, so that's super useful for interviews, as well as a movement scientist from our own department. And together in these interviews, we looked at the relevance of the specific concept. We looked at the feasibility, as well as how can it best be evaluated and what does that accomplish. You can already see we've mapped the concepts to the framework that I started with. And you can see that, well, 3 of the concepts already are in the nice bottom right quadrant that we want. One of them falls outside of this. This is a result of a body storm where it's really hard to constrain users to a specific section. The experts gave a lot of feedback, which was super useful for all the concepts, but the overall preferred concept D as the best concept. What does that look like? Well, the problem that we found was that times were skipping warm-up. The opportunity was that it would be they like spending time on the wall as much as possible, so minimize downtime. And the solution would be a game around a warm-up routine to incentivize users to warm up more using a gamified warm-up experience. Okay, now we have our concept. It is time to talk about the technology which we're going to need in implementing this concept. And the technology is pose tracking. The subsection of motion tracking, and what it does is have a digital representation of real-life user movements, which you can use to gather data for all our systems. And to have this working, what you basically need is one of these joint skeleton configurations, which is a bunch of data points with positions of each of the limbs, which the system can use. How do we get it? There are a couple options. First tracking system is infrared-based tracking, meaning you have a bunch of reflective dots on the body, and our perspective around the user will infer its pose. Second is depth-based system, a camera which can generate a depth map, after which an algorithm can infer the pose that way. Third are inertial sensors, so putting a bunch of inertial measurement units all over the body, which can track using gyroscopes and accelerometers really accurately the position. The last one, which may be most interesting, camera-based pose tracking, because it's really the last decade has been a lot of innovation in that, because it uses machine vision and AI models to infer a pose by raw video feed from any webcam or camera that's out there. From these categories, I've selected 4 systems. This is not necessarily the best system that's out there, but at least the best I would usually get access to. And we're going to evaluate and compare them with each other. And besides just accuracy and latency and the specifications, we're also looking at the specific climbing context constraints. So what is different in climbing that changes this accuracy of the system? So first, if we look at manufacturers' specifications, both literature, the accuracy of these 4 systems, there's a clear story. The inertial and the landing suit is by far the most accurate, while the camera-based pose tracking is the least accurate. I also tried a whole method of comparing these systems based on comparing them against the ground truth, which would be the link suit, reporting their movements and comparing joint angles. In reality, this was inconclusive, as the systems are so different from each other, including the entire software stack, that the joint configuration, amount of smoothing, interpolation, all these differences ended up with a compounding error that was almost impossible to compare against each other. Latency means the time between input and output of a system. So if a movement is detected by a climber, how long will it take before it's reflected into digital representation? We need some end-to-end measurements for that. So the entire software stack, including the visualization and recording. Also, pretty clear story of measurements. And we can dive a little bit more into it if we look at literature, because it teaches us that when you're designing any form of game, which you are doing, there are some acceptable thresholds. So imagine in a very competitive, fast-paced first-person game, needs really low latency. But for our use case, which would be omnipresent type of games, both the Kinect as well as the ambient link would be very much suitable systems. So if we look back in our different tracking systems, we can, during our comparison, really see some of the limitations that each of these systems has. First is the OptiTrack, which is limited by the amount of cameras that are required around a climber. If you're climbing a climbing wall, the front of your body is obscured by the climbing wall, which means half of these cameras do not have line of sight and therefore have no pose at all. So they're disqualified early on. Second is the depth-based system, which works pretty accurately on a flat wall, but as soon as the body of the user is not in the same plane as the camera, meaning on an angled climbing wall, for instance, this accuracy really falls short and is also pretty much unusable. The inertial suit suffered from another limitation. That's because, as opposed to all the other systems, which are absolute, this is a relative type of positioning, meaning it doesn't have a reference point in the physical space, and it can only know its location compared to its previous frame. And because of this, you can see a mismatch compared to the environment in location. And you really have to account for that with some sort of calibration process. The last one was a bit of a disappointment. Camera-based pose tracking did not really work well. That is because, as they are AI models, they are relying on a big data set of footage. And most of these models have been trained on A, not sport specific, data sets, but also almost all are front-facing viewpoints. And with climbing, again, that's 2 days, so the activity also falls short. For our concept of a gamified warm-up, we found that the MVM link suit was best suited if I would not be using a 30-degree incline diagonal wall. I would definitely go for the depth-based system, however, because it's not as intrusive as you don't put, you do not have to put on all these sensors. For all the concepts that we've generated before, I also have a recommendation which system would be best suited for those. Okay, we have the tracking technology, time to implement it in a prototype, and we start by building a climbing wall. So this is in the interaction lab. We had a professional builder build a climbing wall for us. This is the result. And together with Sam, I think he's in the audience, shout out, we put a lot of technology in this, and we call it the integrated interactive climbing wall. So as mentioned, it has the 30-degree fixed incline, but it has also a standardized layout of holes. And what this means is there's an existing database full of challenges and routes, which you can easily use, so you don't have to think of all your own, which is really convenient. It is supposed to function as a sort of platform, meaning not only me and Sam will use it, but also more researchers and students in the future. So it should be easily controllable. So on the side, there's some controls, there's an on-off button, there's a port, so you can connect the laptop client device, which is loaded with our software package, so you can easily control the wall. What does it do? We have 4 main features, which is the tracking technologies that I've discussed, which is a couple of force sensors, so it can measure directional forces on the hold. A protector, which is able to protect the entire surface of your climbing wall, as well as LEDs in every hold. Again, this is from commercial systems where we implemented these LEDs, but we also have their Bluetooth signal to be able to protect our own graphics. Lastly, this is the brain of the climbing wall. It is a server which runs all the data processing for all the incoming and outgoing signals. Also note there's a wireless access point in there, so it can control the wall mostly wireless as well. Also, this is very cozy. I spent a lot of hours in this one. Okay, that's the wall. Time to implement our concept of gamified warm-up, for which we first have to know what does a successful warm-up look like. For that, we asked our climbing coach, Irene, again. She put together a few key features, which is first cardio, aerobic activity, stretching, grip training for stimulating blood flow in the fingers, as well as difficulty ramp up, meaning an easy route at the end of your warm-up before you get to your actual skill level. We can convert this to a more game-like routine, again with as much on-the-wall experience as possible. So that starts with ground and jumping jacks. Unfortunately, cardio is very hard to translate to an on-the-wall experience, so that will have to be done grounded. Arm reach is the goal, as well as the low skill climbing at the end. This is the routine that we will use for the rest of our game to build upon. We started by inviting more users into another brainstorm session using co-design to generate a theme on top of this routine. For that, we've looked at the 3 phases and looked at what kind of game themes would fit best. With a focus on player agency, meaning having the player feel that they influence the outcome of the game. Having as much replayability as possible, so a scoring system to compare not just to yourself, but also others. In the end, we choose a wonderful pilot team. It is implemented really short into a 3D engine with a focus on modularity. So all the tracking systems that we've implemented are connected to a single interface. So with one click of a button, you can switch between them. Same with the game theme. It's easily swapped out by other game themes because the routine is abstracted away from it. This is the final result. This is what the game looks like. Because we're using the inertial measurement suit, we really need a calibration process to anchor to a physical position. So that's what I'm doing right here. After which it is time for cardio. So that's the jumping jacks. In this, there's like a treasure map that reveals by doing jumping jacks. The stretching phase, there are X marks on the treasure map, which you have to do stretches towards to get as much as possible. This is your score. And the last one is claiming your treasure by doing a simple route towards the end. Forgive my horrible climbing, and it's the target. Okay, time to evaluate what we have to do. Remember, our goal was incentivizing climbers to warm up more frequently. For that, the prototype has to first be as engaging as possible. So it has to be more engaging than a conventional warm-up. Second, it has to be as close in effectiveness as possible to a conventional warm-up. So basically, sport readiness has to be maximized, and we're doing that through heart rate measurements, while the engagement is going to be measured using an industry standard survey. The conventional warm-up, we again designed with the help of our coach, which is just a video of me doing all the movements. And that's going to be shown to all the participants for the conventional warm-up. Then it's going to be a repeated measures experiment, meaning a single participant is exposed to 4 different sessions, 2 of the conventional warm-up, 2 of the novel warm-up. And then it's time to recruit some participants. The participants that are recruited have to adhere to a few criteria. The first is the climbing skill rate, which is actually pretty important because they have to be not too skilled as the persona that I'm targeting for this concept is a beginner to intermediate climber, but they also have to be at least a minimum skill level because the wall with the fixed or incline is really hard to climb at, especially for muscular endurance. So they have to be skilled enough. And of course, they have to be uninjured. After which, ran a short pilot test, which can improve the prototype a little bit before the final evaluation. And we ended up with 12 participants. And these can be divided into 2 sequences, half of them starting with conventional, half of them starting with the novel one. Okay, engagement. What did we learn? First, we just simply asked users which has your preference and which most participants prefer the novel one, which is good. They also mentioned they would incorporate, at least to some degree, the novel warm-up into their existing training. If we look a little bit more deeper into the data, we have our survey, which is the user engagement scale, which has a few subfactors. So focus, attention, aesthetic appeal, perceived usability and reward. And these are subfactors of engagement, which using randomized questions are all measured with a single questionnaire. Luckily, these questions had good internal consistency, meaning participants had similar scores for questions within a single factor. Also, all factors are statistically significant, which means we can actually say focused attention is significantly higher in our novel prototype versus a conventional one. Also, no correlation was found between the outcome as well between the outcome and the sequence, so starting with conventional or novel, as well as demographic data such as age, skill level, and height. If we look at specific aspects of the prototype, what works best and what doesn't work as well, we can clearly see that the on-the-wall part, which might be expected, scored really well as the game and physical tasks, so routine. What didn't score as well was the board configuration. So our 30-degree system board that we have was not very much liked by users, leading us to believe that a different system board would really improve the engagement much more. If we look at effectiveness, we start with just a perceived perspective, effectiveness by users, by asking them, that's still pretty clear. There was no significant difference between the 2 conditions, meaning they felt it was as effective. But if we try to back it up with more quantitative data, it's a little bit of a different story. This is the heart rate data of a single participant. So you see the 4 sessions that they did, 2 conventional, 2 novel. You can see that there are some differences. If we look at the whole population, you can see that the novel routine has a much higher heart rate than the conventional routine. And this is especially true if we look at the specific phases in the warm-up. So the first cardio phase is still pretty similar between the 2 conditions, but especially the latter 2, because they are translated to an on-the-wall experience, they really start to differ. Unfortunately, I was not able to conclusively compare these between the two conditions, and that had a couple of reasons. First was the heart rate sensor kept crashing. It's really annoying. But also to accurately compare them, I would need to label this very accurately for each participant, these three phases. And in reality, that was very difficult because it was just hectic during the experiment, but also because there are a lot of variations between participants. Some needing to put on their climbing shoes, drink water. There's just a lot of different timings, which made it very hard to compare. So this was still pretty inconclusive. Conclusions, what did we learn? Well, for engagement, it's pretty simple. We can say that the novel prototype definitely increased engagements compared to a conventional warm-up. Effectiveness seems to perform close, but it's based on qualitative measures only and not on quantitative. Okay, with our conclusions, we can start to look back a little bit on what we did, and especially what can be done in future research after our study. First is that we did prove effectiveness or engagement for our prototype, but we did not yet conclusively say if this actually would decrease injuries or if climbers actually would incorporate this into their warm-up. So having future studies over a longer term to observe participants could prove this much more. Of course, I generated a lot of other concepts which are both based on our problems, opportunities, and solutions, but also are tied to personas and have a very specific climbing system, tracking system compared to recommended for that concept. So there's an opportunity for future work to find out if that works too. A new prototype has some very simple improvements. First, please use flat climbing wall. Second, the body of the climber can sometimes obscure the projection. So for that, we really recommend a couple of short-throw projectors which could go around this issue. And lastly is that we found that the pirate theme that we generated was found fun by some climbers, but also a little bit gimmicky and unnecessary for some other climbers. That means it's more focused towards playification from literature than gamification. And we really, for next prototype, should decrease this focus on the theme and narrative and more towards the point system and just make it a little bit more abstract, basically. In my process, I also could have done a lot of things different. First is that the reason the playification also had a big focus was because of our co-design sessions. And I think with a more structured approach, based on literature, less involvement from users and more from expert game designers, I think the output of the team would be much better. Second was that the conditions that we measured, basically we have reason to believe that on-the-wall warm-up works better and that gamification might work better. But we tested that in one single experiment. Really, if we would have separated those into multiple conditions, we could have more conclusively proved that these subfactors actually are the reason or the cause for improvement. Lastly, is that we really should have a better approach to quantitative measurements for effectiveness. So that can be HR, heart rate, but also heart rate variability, which is promising. But then including resting phase beforehand, recovery phase afterwards, a working heart rate sensor, and a structured approach to labeling the specific phases of the warm-up. And those are most of the lessons that I learned, which means done with presentation. Thank you very much for listening.